In this video, we're going to be talking about conic sections, and we're going to be talking about one in particular, and that's the parabola. A parabola is formed when the plane intersects one nap of the cone, and that plane is parallel to our side of the cone, which we call the generator. So because it's parallel, it's only going to intersect one of the naps, and it's going to form this arch shape that we know as a parabola. Now, because we're talking about conic section parabolas, we're not restricted to talking about functions, because many of the conic sections are not functions. So we're not restricted to the functions that we know for the parabola. So there are four different forms, four different shapes that parabolas can make. And we're looking at parabolas with their vertex at the origin. So this graph in blue here, these are our parabolas, but they have some features that we haven't talked about in our parabolas before. So we have our vertex at the origin. This point F here is called the focus. And then this line down here is called the directrix. So the focus is A units away from our vertex. And the directrix is the same distance from our vertex as the focus, but in the opposite direction. And it's always a horizontal or vertical line. So if our parabola opens up or down, it's going to be a horizontal line. If it opens left or right, it's going to be a vertical line. Now, one thing that you can see is our parabola always opens toward the focus. So if the focus is above the vertex, that means our graph opens up. If it's below it, it opens down. If it's to the right, it opens right. If it's to the left, it opens left. So what do the equations of these different forms look like? So if you have a parabola with its vertex at the origin and its focus is above the vertex, we know that this opens up, so it's going to be a parabola in the form of y equals x squared. So it's an x squared variety. But it's not just equal to y. Instead, we have it equal to 4a times y. And this 4a is going to be helpful in letting us find the value of the focus. Now, if this value is positive, that tells us our graph opens up. Since our graph opens down, all that changes is that this 4a value is negative. So it's still an x squared variety, but now it is a negative 4a times y. So in this, we have a parabola that opens to the right. Now, we haven't really dealt with these before, but the thing that's going to make our graph open to the right or left is by making y squared, by squaring the y value. So this is y squared, and this time our focus is to the right of our vertex, and that happens when the value of a is positive. So we have 4a times x. With the focus on the left, that means that a is negative. So we'll have y squared equals negative 4a times x. So these graphs, these equations all look very similar. The only thing that really changes is which value is being squared and whether the value of 4a is positive or negative. What value is being squared is going to determine whether it opens up or down. So if it's x squared, it opens up. If it's y squared, it opens left and right. So x squared opens up and down. Y squared opens left or right. If it's negative, it'll open down or left. If it's positive, it will open up or right. So we talked about A, and we want to know what is A. Well, A just represents the distance from the focus to the vertex or from the vertex to the directrix. So A is the distance, this distance here. That distance is A. And it's just the distance from the focus to the vertex. So A is the distance from the focus to the vertex. Now, if our focus is above our vertex, the value of a is positive. If our focus is below, it's negative. If our focus is to the right, it's positive. If it's to the left, it's negative. Now, there's another thing that we use a for, and it's actually, there's another feature on a parabola. So there's a few things that we know from before. We know that we have an axis of symmetry. Parabolas are symmetric about this axis. We know that there's the vertex. What we've learned today is about the focus and the directrix. But there's also another feature that we can use to help us when graphing and be a little bit more accurate. And we call it the lattice rectum. And the lattice rectum is basically, it's a horizontal line that connects, whose endpoints lie on our parabola right here, like this, and whose distance, whose length, the length of the lattice rectum is 4a. So we call this the lattice rectum. And the length of the lattice rectum is just 4 times the distance from the focus to the vertex. So the lattice rectum has a length of 4a. Now, we only use this really when trying to graph our parabola to help us make our parabola more accurate.